Okay, last week we talked about object-oriented programming, and today we are going to talk about a part two for object-oriented programming. This is the second programming paradigm we talk about. First one is the traditional structured programming, imperative programming. And then we talk about this object-oriented programming. So object-oriented programming become popular because of the window programming. People start to design GUI and require a lot of the library. Okay, we call it foundation class, and later we call it API. Okay, and then object-oriented programming become more popular. And nowadays, they start to do AI, so more functional programming become popular. That would be the topic for the next week. Before we get started, first I would like to ask, is there any questions so far for this class? Any questions so far?
No.
No question. Okay, then we'll continue. Okay. So this week we are talking about class-to-class relationship. Last week we talked about basic class design. So this week we are going to talk about class-to-class relationship. So class-to-class relationship basically have two kinds of the class-to-class relationship. One is called is a relationship. The other one is has a relationship. So is a relationship is for the inheritance. Has a relationship is the association or agreement. Okay, that's actually called has a relationship. So this whole thing talking about class-to-class relationship and approach class and the functional closure. Okay, so today these are the different topics about class-to-class relationship. So Python do not have interface. Python only have class, same as the C++. But interface is a special concept in Java. Okay, so when you study the object-oriented programming, different language still have. Okay. So first, we talk about encapsulation. So encapsulation is to make a module for a certain class. That means that you try to hide the technical detail in your class, and then other class or program want to use that class need to go through the interface, and the interface usually is the parameter, the functions, okay, the accessor mutators. Okay, so that actually is information hiding and data encapsulation. So in Python, you had a LEGB rule for the scope. Okay, for the scope. You need to know about where the variable got defined, okay, or first used. Information hiding encapsulation mechanism enable the programmer to group data and subroutine that operate on them together in one place and hiding the details. So this one I see is okay, not hard. So usually you have a name, okay, then that is a public variable. And then one underline that's usually is protected. Okay, two underline that's actually usually is private. So private variable usually outside cannot see it. And then if you have underline dir underline. Okay, this kind of the variable double under variable or double under function, they are private. Okay, they are private because they have a double under there. This is double under. Okay, two underline. Single underline is considered protected. Okay, so protected usually those variable or function can only be seen by only the subclasses. Subclasses can see it. Okay. If not the subclasses, then you cannot see those variables. Okay, so that's actually let's see. Okay, before we go forward, before we move forward, that's actually print our idle. That's actually the interpreter for Python. Okay, I usually keep a batch file link on top of my desktop. Okay, so right here, let's see. You may say let's see. You may have a class. A, okay, and then define init. Okay, let's assume this is the class A, right? So you can type A. It is a class type. Okay, it is your class type. And then let's see, we can do print A dot underline dir. Okay, so this dir is a method. Okay, it's a method. So you say that it's a method of the object. Okay, so A do have a dir variables, and then print A dot underline doc. None means undefined. Okay, none means undefined. Let's print out the slides last week. So these are the different attribute names. Okay. So let's look at another one, that underline tick. Okay. Let's look at this one called print A that underline tick. Okay, so here you can see that there is a variable called module, and that's main. There's init, that is a function. Okay, so this whole dictionary have everything that you have. Everything that you have is inside the dictionary. Okay. So that actually is all of your property is defined in the dictionary. So that actually is available that every object has. Okay, every object has. So these are the class attributes or in the Python. Okay. Okay, so that's that. So they are private variables and public variables and public private methods. Okay. So default in Python, if you don't write anything, that would be public. Okay, that would be public. So here you have music class init. You have full function, so you can run the full function. You can actually print out generic variable. You can print out the singer. But this one, they are They are what? They are actually public variables. They are instant variable because you have cell. So they are instance variable, but they don't have the underline, so they are public. Okay, they are public. So let's see, let's actually try this. So we can create a new file, okay? Let's save as first. So let me go to E drive, go to the directory I want to store. Right here, and Python. So right here, we are on chapter 6, okay? Let's create a chapter 6. Okay, so let's actually work on this chapter 6. And this one, let's call it point. Okay, so it's a point.py, so we have a class point, and then let's define init function, and then cell, and then x and y, two variable, and then cell dot. Let's use a private variable, so underline x equals x, and then cell dot underline y equals y. Okay, let's have this one, and then let's define actually underline str underline, okay, cell, and then return. So str of the underline x, str of the underline y. Let's assume that we actually have this class. Okay, so the instance variable are private. So in that case, let's try actually P1 equals point of 3 and 4. And let's print now the P1 dot underline x. Okay, and print now P1 dot underline y. Also print now P1. Okay, let's actually look at this 3 print. And let's run. So when you try to print the underline x, it said that a point that has the big attribute of the underline x, because they are private. Okay, they are private. They do not allow you to access the private data from outside. So now let's actually delete the underline, and then make it a public variable. Then that will become a public variable. Let's run it one more time. Oh, I'm sorry. The print, I should not have the underline. Sorry. X is not defined. I'm sorry. This one should be cell.x, cell.y. Okay. Okay, so you will get the right result then. So be careful that be careful about the private variable when you do the underline. Okay, we call it double underline. Okay, D under variable. That actually it would be private. Okay, then let's continue. So that's a private attribute. So underline function is also a private function. Okay, this part, okay, let's see. I think this one okay, not important. Okay, sometimes you have the add property that's actually a decorator. Okay. This allow to overload the full function. So okay, the decorator is the separate issue. Decorator is a wrapper of the class. We'll talk about it later. Okay. So then we move on to the classes and the object for class relationship. Okay, here talk about the design of a class. You need to spend time to look at the basic guideline to design a class. Let's move on, okay? So class to class relationship, first kind is the association time. That means that one of the class use the other. But sometimes it's one to many. Sometimes is let's see here, it actually is many to one. Okay, sometimes it's many to one, sometimes it's one to many. Okay. So one to many is called aggregation. Okay, because library has a lot of books. So that's one to many, that's called aggregation. Many passengers take an airplane, that's called association. Okay. And then one to one is called composition. Okay. Composition. So these are different names for the association, aggregation, and composition. Okay, composition means one to one. Aggregation means one to many. Association means many to one. Okay. And then there are different symbols, solid triangle, okay, diamond, okay. But usually this kind of the association, sometimes you can only use a single arrow to represent it, okay? These three, association, aggregation, and composition, can also share the general name of the association, okay? And you can use a single arrow for it. The inheritance will use a different arrow, that's actually triangle, okay, white triangle arrow. Okay. So inheritance, so the so-called inheritance is that you have a memo, and then dog is one kind of a memo, so you call it in its a relationship. And then cat is also a kind of memo. So this one is the inheritance relationship. Okay. So let's actually use a Java to show the this kind of relationship better. I like to use this Bujay tool. I use this tool to teach high school students because this one can show the class-to-class relationship better, especially for high school students. So right here, let's actually create chapter 6, okay? So to explain what is a relationship, what is has a relationship, let's try to have, okay. First one, let's have baseball team. Okay, so baseball team is a class. So this baseball team actually will have 9 players. So let's see, we may create a class called player. Okay, so this player class, each player may have, let's see, each player may have a string, that's name tag name, and then that actually may also have a double variable that could be its batting average. Okay, it's batting average. Okay, so you do have the constructor player, string n, and then also double batting average. Okay, so your name equals n, your batting average equals b. Okay, let's assume that this is a player class. Then you have a baseball team. Your baseball team may have 9 players. Okay, then let's just write up to here. We don't care about the performance, but as you can see, this tool, they give you this arrow. That means this has a relationship. You use the dash 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 arrow line for the has a relationship. We also call use relationship or have relationship. A baseball team use 9 players. A baseball team has 9 players. Okay, so this one is actually baseball team using has a relationship. Let's actually try another one that's called basketball team. Okay, now we have another one called basketball team. So this basketball team, we do not have anything, but here we do import java.util.array list. Okay, so right here I say extends array list of players. And then it's done. We do nothing else. Okay. So this one is a relationship. This creator is a relationship because a basketball team, okay, I have multiple L. We need one more. This basketball team actually is an array of players. So basketball team inherit an array list of players. Okay, but right here, actually, it doesn't show that the basketball team inherit the player. No, it doesn't show it because it doesn't inherit the player. It inherited. It actually inherited the array list of players. So with that, when we test it, we say test basketball team. So we say basketball team, let's call Yankees, okay, equals new basketball team. And then we can have Yankees A. new pair of arm, and then the betting average to be 0.24. Okay, and then we add more. Okay, and then we print out the Yankees. Okay, anyway, in our, okay, so right here, baseball team use the player, okay? And then basketball team, basically, there's nothing, we do nothing right here. We do not add anything or design anything right here. But in fact, when you use the basketball team, you can use that to add elements. So this add function is coming from the array list of the players. So the function defined in the array list. So basically, this is a relationship. The basketball team inherited the function from the array list. Okay, from the array list. So this is a relationship, but it's a relationship your child class, the basketball team, may not have any definition. That just take everything from its parent. So there is a parent called array list of player, and then its basketball team inherited it. Okay, so this is a tool which I show you the class to class relationship quite well. Okay. Okay. Any questions so far? Any
No.
questions so far? No?
Good.
Okay. We try to explain the class to class relationship. Okay. And then one thing is that in the Java, we use the so-called mix-in inheritance. So one class can only have one parent class. It can only extend one parent class. Okay. And then multiple interfaces. That's called mixed-in inheritance. But in Python, you not allow multiple inheritance. Okay, so Labradoodle actually inherited Poodle and Labrador. Okay, Labrador dog. Okay, so it's called multiple inheritance. So when do we use the multiple inheritance? Let's go back to Python. When do we actually do multiple inheritance? So let's actually finish this one up. We have the point. Okay, so this is the point. And then let's see. Let's create another one. Okay. This one, let's actually call it class. Let's call it class rectangle. Okay, so define underline init cell, and then width and height. So self that width equals width. Self the height equals height. Okay, so this one you define a class called rectangle. At the same time, you may define another class. Okay, this one let's call it warm color. Okay, so you define init still, and then you have color. So self that color equals color. Okay, so you have these two classes, but you can define another class. Let's call warm color rectangle. You extend rectangle and the warm color. Then you do define init. So you have WH and color. Okay, and then you do let's see, super that init. Let's see, I'm sorry. Let's see. Actually, you actually need to do super and init. So it's called super init. You need to call super init. Okay. Let's see. So you do super then init. Okay, and you put W and H. That actually is the first one you rectangle. Super that init. And you get your color. Okay. So you can create a one color rectangle one equals one color rectangle 3, 4, and then white. White is not one color, let's call it red. Okay. Let's just run it. Missing one rectangle. Let's see. Let's actually try Let's try this. Let's try, don't use the super. Let's try rectangle. So let's try warm color. They not allow. Let's see. Rectangle indeed missing one positional variable height. Indeed. Let's try put the cell in. Okay, then this one work. Okay, this one work. Passing the argument. So basically, you can separately call in the class with the constructor, and you must put the cell in there as well in order to call the constructor. But basically, you can have a rectangle class and a warm color class, and then you have the warm color rectangle to inherit both. Any questions so far? Any questions so far?
All
No?
good.
So these are the multiple inheritance. So multiple inheritance usually, if you are in Python, usually that you kind of use a few classes as the interface to get more feature. Okay, usually like that. Usually data you just come from. Still, we actually encourage you just use the data from one base class instead of multiple. Okay. So basically, your derived class may have the feature one, feature two that come from the base class, but you may add one more feature. Okay. So usually derived class is bigger and more specific, and then base class is smaller but more general. Okay, this is about the inheritance. Then your subclass can override the method definition of your superclass if you redefine it, okay? But that redefinition of the function must have the same name and same variable list, okay? That's called overriding of a method. So Python has the multiple inheritance. So if your base class has feature one, feature two, and another base class has a feature three and feature four, you can combine the base feature from both class, and then you may also have your own feature. Okay, it's multiple inheritance. But when you actually do the method resolution, so which function, if there is multiple definition, it will go by left to right, depth first order. Okay. So left to right, depth first order, that's what's that. When you have multiple parent, so it will be left to right and depth first. Okay, so if you have this many inheritance, let's assume that you have very complicated inheritance structure. Okay, then you will go for this one first, left to right. So it's 1, 2. Okay, finished. And then you go to 3 and 4, and then this one. Okay. It's very complicated. Okay. Anyway, let's call MRO. As for detail, how really the order work, you have to exercise the rule. It's called Python MRO order. Okay, you have to study it. Okay, here you have the detailed description of how they are determined. Okay. So you have to figure it out. You can read this one. Okay, you can read this one from Geek. So that's actually you need to figure out the order of the multiple inheritance. Usually don't make it so complicated. Usually multiple inheritance. Usually it just uses one superclass and the other one as the interface. That actually is better. Okay, like, don't try to create too difficult inheritance paths so you cannot understand by yourself. Okay, so here to show you the inheritance order. Okay, 1, 2, 3, 4, 5. Okay, I don't know. It's 1, 2, 3, 4, 5. This one actually is the order of the dynamic linking. This one is not order of the super constructor order. Okay, super constructor order should be reverse. Okay, should be reversed. Should be reversed. So here you show the different example how this MRO will be done. Okay, anyway, we don't go too much time, spend too much time there. Next one is the class diagram. You need to draw your class diagram. Okay, many things depend on the class diagram. For example, this multiple inheritance, the order of the constructor and the dynamic linking will depend on this order. Okay. So anyway, I don't spend time to go into the details. You can figure it out. Okay, you can figure it out. It spend some time. The next one is a super function. The super function will source the super class for you. Okay, but when you don't want to source, if you don't want to source, you want to be the specific class, you just use the class name. Okay, that actually should be fine. If you just use the super, then you will actually find the first one that is its own parent to use. Okay. Okay, anyway. They say that we do not need to simplify the base class name, but if you need it, you still can do it. Okay. That actually is a rule. Okay, single inheritance. If there are multiple inheritance, then you need to figure out how they call the constructor. Okay. Okay, anyway. We don't spend time on it. You can study it. Okay. Command line arguments, you have Python, then Python global name and argument. This will be passed into the system variable called system dot argument vector. Okay, and you can use the system dot argument vector length to figure out how long it is. Okay. So import the sys and then you print out length of the system argument. You will know how many arguments there are. And then you can also print out the string of the system argument. System argument is actually a list. So when you do Python command line py a b c d e, there will be 6 elements. The 6 element would be command line py, that's actually argument 0, and then 1, 2, 3, 4, 5. Okay. Any questions so far? Any questions so far? No? No question?
No, all good.
And then you can also do get options. Okay, get option is a function that you can get the option. So usually you have, when you write a program, you have, say, run, right? Run program, and then you have A, B, C. These are arguments. So it will be coming back from argument vector. Okay. And then you may have dash OP, okay, dash P32. So these called argument options. So Python also provide get options that you can use. Okay, C++ also has that. So you can run get option that you need to import get option module, and then there's a function called get options. And then you have the option, argument option, and okay. So right here that actually you can do while get option argument count, how many argument you have, and argument vector. And then these are different options. So you get one by one, get by one by one, get one by one, until it's not equal -1. Equal -1 means that you run out of it. And then you will, when you have a C equals the option. So the option will be the so-called option type. Option type is dash S. Your C will be S. Dash H. Your H will be your C will be H. Okay, and then different option you get it. And then there's a variable called argument option argument. That is when you do dash S 32, then 32 will be passed to argument option arguments. Okay, and then it actually do A to OI. A to OI is converting the string to integer. It's an A to OI function. Oh, actually this one is C language. Okay. Any questions so far? Any questions so far?
No.
This one is C language to process the option. Okay, so that's that. So here we have the Python version. So Python version will return options and arguments. Okay, so action, argument vector, and then this one I think is the options. Okay, so basically you get these, and then you will store all the option in options, argument vectors, option arguments in argument S. Okay, and then you do analysis. Okay, anyway, this is similar to C language, but you have to understand it. Okay, try to understand it. Okay, and they are tester. Okay, you can do. Next one is match variable. Match variable, you have star arguments and double star keyword arguments. KW, keyword argument. Okay. Okay, this is actually related to the grouping of a variable. Okay, before we go into the grouping of a variable, let's look at a function. Okay, let's look at a function. So typically when you design a Python function, let's actually create a new file. Okay, you create a new file. So basically you can define square of x. Okay, you can put a hint. Okay, so you can put a hint of your return integer type. Okay, and then you say that you will return x squared. Okay, and then you do print of x squared equals x. I'm sorry, square of x. Okay. And then before that, you need to define your x equals 3. Okay, let's do this one. So this is one function, okay, one basic function. Now, so sometimes you may want to have default value. Okay, so let's do define square x equals 0 and then return x squared. So this one, if I do not have the parameter, so I say print, okay, x square equal, this one is x square of 0. And then we do x squared. So if you don't provide the argument, then here you can define it as a default value. You use the equal sign. So this one is your parameter, and your default value is 0 if no parameter being fed to the function. Okay, so that one you should get a 0. Okay, you should get a 0. Any questions so far? Any questions so far? No?
No.
No next one. No next one is that define actually print data. So print data, we do have this one argument as. So we will print the length of the arguments. We will print the type of the arguments. So this one we call it grouping the arguments into a list. So you have a star, then you will be grouping all of the available arguments into a list. So let's do actually print data 1, 2, 3, 4, 5. So in this case, when you print, it actually is a tuple. Okay, I'm sorry, it's not a list. It actually is a tuple. Okay, actually the tuple. So the length is 5, type is tuple. So that's actually print the arguments. Okay. Not only print the type, but also print out the argument. And you get a tuple. Okay, you get a tuple. So that actually is grouping the argument into a tuple. Any questions so far? So that is the purpose of the star argument. That's grouping the whole parameter list into a tuple. So next one, if you do define a function that's called a dictionary, and you say name, I'm sorry, double keyword arguments. So that would group the keyword equal value into a dictionary. So let's just do printing of these PW arguments. Just printing it. Before we print in the content, let's literally print the type of the keyword arguments. Okay, and then when we run create dictionary. Name equals Eric. Age equals 20. GPA equals 44. Let's run this one. Oh, I have multiple W. That's actually here. We need a W. That's a typo. Okay, so we create the parameter list into a dictionary. Okay, we talk about this because later when you go to the functional programming, this is very important. Okay, this will be very important. Any questions so far? No question, we move on, okay?
No.
So these are the magic variables, and then you need to know about the grouping of a variable into tuple and then grouping of a keyword arguments into a dictionary, okay? So we have example, but I don't want to waste my time to do it. These are detail, you can study it, okay? Abstract methods, if you don't want to implement some function, you want to make it as an abstract function, it is also okay in Python. Okay, that's actually unimplemented function. Okay. So in that case, you will need to use a keyword. You use a decorator, so abstract function, and this one will become an abstract function, undefined. Is that okay so far? Okay. So, but you need to include the abstract methods module. Okay. Okay, anyway, this one I just talk about how to add abstract functions. And then polymorphism is doing dynamic binding because Python is fully object-oriented. So basically, there is no static binding. Okay, everything is dynamic, so it's okay. Okay, this part should be fine. Introspection. Okay, introspection. So introspection is for self-examination. Okay, introspection refers to examine of one's own thoughts, feeling, and motivation and actions. Okay, so Python support introspection, run deep, and wide throughout the language. So basically, you can go through deeply into the function. Okay, for it. So they are introspection. And basically, usually you use the sys module to help you to do it. Okay, then you can figure out your version, your argument vector, your path, your modules. Okay. You can check it. Okay, here we just give you the to let you know that we have this different module because we have limited time, so we cannot go into the detail of each introspect functions, but you can check which one you can do what. Okay. Okay, this part. Okay. The last one we'll talk about is a duck typing. Duck typing is like interface. Okay, like interface. So actually, it's a function that everybody share. We call it duck typing. Okay. So duck typing is implicit interface. The idea is that when something do the same thing, okay, if you quack like a duck, then you are a duck. That's what it say by duck typing. Okay. So duck and goose are different object type, okay, but you do not need to declare their relationship. But when you perform similarly, and then you are considered you are the same type, it's called duck typing. Duck typing means that if you walk like a duck and you walk like a duck, then you are a duck. So you have a duck that can walk, and then you have goose that can also walk. Then goose walk like duck, so goose is also one kind of a duck. Okay, that's actually is the duck typing. The idea of duck typing. Okay. Okay, so no need to declare interface, just define polymorphic measure of the same name in different class. This is called duck typing. So the idea is that they will work in the same way and they are considered to be a duck type. Okay. So duck can quack, duck can fly, person can quack, person can fly. So basically, in the forest of something, then this is seen originally in Java, you need to have an interface in order to create a genetic method, but right here you don't. As the scene both quack and fly, this scene is a duck type. This person is also a duck type, okay? Because your duck and person quack and fly in the same way. So now you have duck, goose, and person. All of them can do quack and fly. Okay. So Python is a dynamic type language and Java is a static type language. Static type means that the type is determined at the compile time. Python is determined at the runtime. Okay. Python is a weak type language because a variable name later can be assigned for different type. Java is a stronger type one, so you cannot change the type in the middle. Okay. But Python has a type inference. Java does not. Okay, type inference based on the data of its origin. and then determine the type, okay? Okay. Okay, so far we actually pretty much finished this chapter. There are details, but you can study it, okay? We just give you the material, but you still need to study it. Last topic is the function closure, okay? Function closure is the object that actually perform polymorphic method. So what this one really is that, let's see. Okay, last time we have a class called polynomial, okay? Polynomial, let's actually define something. That's actually have a class, let's call it, let's see, let's call it, okay, let's call it square. Okay, just call it square. So this square, you would have a defined init. No, that's actually just define init, okay? Don't provide available, let's just define init, and this just do pass, do nothing, okay? And then define some function called call, and then x, and this one you will return x squared, okay? And then let's actually define another function called cube. This one also do nothing, and then that also have a function called call function. This one will return S3. Okay. So now we do have two class. Each one has a call function. So this we talk about this one, right? We talk about is a call function. So what is the call function will do? Okay. So then we may have, let's see, uh, let's do define long, okay, and then we have function and then x, okay, and then we will return function, long in the function with the x, okay. So let's call order 2 equals square, okay. Order 3 equals cube. Okay, let's create two object, okay. Each object is a function closure type, okay. Then let's do a equals 5, okay. If a less than 6, then okay, here let's actually have a x function, okay, equals 0. Okay, let's assume that. Then this x function will be equal order 2, else x function will be equal to order 3. Okay, and then we do run x function with 10. And then at the end, we print the result. Okay, so basically X function is the function object, class object that you have. And that class function, when you call the function, then it will return the value for the call. Okay. So when this you have a call function that your class object can be a function closure. That means the object can be run. Okay. Anyway, this is function closure. Okay. So you can study, okay, and then this is the end of the chapter 5. Any questions so far? Any questions so far about your homework or anything so far?
I don't have any.
Okay, if no question, then next week we are moving on to the functional programming. Okay, see you next time. Bye bye.